In this video, we're going to talk about interpreting position and velocity versus time graphs like you've been doing with the motion detectors. So we're going to step through kind of what you should have seen, what you've been looking at, and what that all means. So again, first off, we're going to start with how are these graphs generated. So again, the sound waves are being sent from the sensor over here on this side, and they're going to bounce off the object. Again, they're going to bounce off the nearest object. So that gets a little tricky when dealing with people because arms are going to move, your body's going to rotate side to side. So different things are going to cause the graphs to not be perfect. But what it does after it bounces back is it calculates the distance away by using the speed of sound and the time it takes that sound to return back to the motion detector. Okay, so in this position versus time graph, what does it mean? What's it telling us? Well, what do they indicate? Well, they indicate where an object is at any given point in time. So basically, how far away from the detector is that object? Couple things here. The value of the slope indicates the speed. So basically how steep that slope is in this direction is what's going to tell you how fast that object is going. Okay. The sign of the slope is going to indicate direction. So because this is a positive slope, we are moving away from zero. Remember, this is the zero position or the origin. So we're moving away from zero. So that means a positive slope is going to be a motion away from the detector. A negative slope, which would be a line going the opposite direction, like so, would mean that we would be going toward the detector. So now you're going to have a couple practice problems to try and answer some questions that go along with it. Now on to velocity versus time graphs. So in velocity versus time graphs, they indicate something a little bit different. They're going to indicate speed and direction of motion. And how it gets that is it basically takes one position, subtracts a previous position from two different sound waves, and divides it by the time it takes for those two different sound waves to get back to it. Because of that, it's going to allow it to find out how fast, but also which way you are going. Speed is determined how far away you are from the origin. So the origin is here at 0 meters per second. The further you are away from it, the faster you are going to be traveling. The direction in this case is determined by sign. So away from the detector is going to be this direction. Towards the detector is going to be this direction. So we're going to say this is the positive direction of velocity. This is the negative direction of velocity. Okay. And you can use those cues to kind of work through descriptions of motion of other objects and their speed and direction. Now that we've worked through the four problems and gone through the couple graphs, hopefully you realize couple major things here. So the value of slope for the position graph determines the speed and the sign determines the direction of motion. So again, from the position graph, the slope tells us speed and direction. Well, the velocity is also, the value for the velocity is the speed, and the sign of velocity is the direction. Thus, the slope of the position graph is the velocity graph, or another way of saying that is the velocity graph is the instantaneous slope of the position graph. Basically, that velocity graph tells you what is the slope of the position graph at any point in time. So hopefully this all is making sense. If you have any other questions, don't hesitate to reach out and ask.